Number patterns, recognizing a rule and continuing a pattern. If you're asked to find a rule for a pattern, some things to check are the following. Are you adding or subtracting the same number each time? So if we had the sequence 4, 7, 10, 13, 16, we can see to get from the 4 to the 7, we add 3, 7 to 10, we add 3, we add 3, we add 3. Or you could have a different pattern like 20, 18, 16, 14, 12, and hopefully you can see that each time we're taking away 2. Or are you adding or subtracting numbers within a pattern? So the numbers 1, 2, 4, 7, 11, 16. Hopefully we can see to get from 1 to 2, you add on 1. From 2 to 4, you add on 2. 4 to 7 is 3, and then 4, and then 5. So we're starting by adding on 1, and then 2, and then 3. Or are you multiplying or dividing by a fixed number each time? So you could have 3, and then 15, and then 75, 375, 1875, and so on. Or 3000, 1500, 750, 375, and so on. Or you could be adding the 2 previous terms. So one example of this is called the Fibonacci sequence, and it starts with 1, 1, 2, 3, 5, 8, 13, 21, and so on. So to get the 2, we've added 1 and 1. To get the 3, we've added 2 and 1. To get 5, we've added 3 and 2, and so on. So example 10. Write down the rule for getting from one number to the next, and hence the next 3 terms in each of the following patterns. So to get from 2 to 4 to 6 to 8, so that's a difference of 2, difference of 2, difference of 2. So the rule from getting from one term to the next is add 2 each time. And the next 3 numbers are going to be 10, 12, and 14. 20, then to 17, to 14, and to 11. 20 to 17 is take away 3. 17 to 14 is take away 3. Take away 3, so this time it's take away 3 each time. And the next 3 terms are going to be 8, 5, and 2. 5 to 7 to 11 to 17. So to get from 5 to 7, we add 2. 7 to 11, you add 4. You add 6, and you add 8. So what we're doing is we're adding the even numbers each time. And the next ones are going to be 25 plus 10, which is 35. 35 plus 12, which is 47. 47 plus 14, which is 61. Example D, 1, 5, 25, 125. So hopefully the way in which these have been done, it's clear that we're multiplying by 5. So 1 multiplied by 5 is 5, times 5 is 25, times 5 is 125. So the rule each time is multiplying by 5 each time. And the next 2 numbers are going to be 625, 3,125, and 15,625. And the last one, 4, 5, 9, 14, 23, and 37. Well, what we can hopefully see is that 9 is equal to 4 plus 5. 5 plus 9 is 14. 19 plus 14 is 23. So the rule here is to add the 2 previous terms. So the next term is going to be 37 plus 23, which is 60, and then 60 plus 37, which is 97, and then 97 plus 60, which is 157. Rectangular numbers. So any number that can be shown as a rectangular pattern of dots is a rectangular number. And what we've got is 12. 12 can actually be arranged in a couple of different ways. So what we could have is a 3 by 4 rectangle. So we could form 12 that way. Or you could do it as a 6 by 2 rectangle. And what we're doing is we're just trying to form a rectangle. Now 5 can't be formed into a rectangle because it's just a single row of dots, and that's a line rather than a rectangle. So you need 2 dimensions for a shape, for a rectangle, and this has only a length rather than a length and a width. Whereas the 2 arrangements we have for the rectangles already, that has length and width rather than just a length. Similarly with square numbers, a square number is any number that can be shown as a square patterns of dots. These are important numbers, and you should be familiar with the first 12 at least. If we consider the first few, the patterns of dots, we can easily see that we can work them out by just multiplying a number by itself. So the next one we can see is 3 squared. So there's 3 along the width and 3 in the height. So 3 times 3, or 3 squared, which works out to be 9. We could do with 4. So the next one's going to be 1, 2, 3, 4. And there's going to be 4 rows of 4 so that we can form a square. So that's going to be 4 times 4, or 4 squared, which is 16. We could do the same for a 5. So we've got 5 rows and 5 columns. And that forms a square. So that's going to be 5 squared, which is 25. The next is going to be 6 squared, it's 36. 7 squared is 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. And 12 squared is 144. And the thing with all of these numbers, they can be arranged to form a square. So we've had rectangular numbers and square numbers, and now we can look at triangular numbers. And triangular numbers are, surprise, surprise, numbers that can be formed into triangles. So we've got the first one is a dot. The second one is a triangle. So we can see that it forms a triangle. And it has 3 dots. The next arrangement has 6 dots. Then we would have, so we have a row of 1, a row of 2, a row of 3, and then a row of 4. And that gives us 10. Then we have that plus a 5th row, which is going to give us 15. Then we'll have those 15 plus a 6th row, which is 21. And then finally, the same diagram, only with a 7th row, which is then 28. And we can see that for each of them, they form a triangular pattern. We had briefly mentioned the Fibonacci sequence earlier on. So these are the first 9 numbers in the pattern. So we've got 1, 1, 2, 3, 5, 8, 13, 21, and 34. And what we hopefully can remember or see is that the 2 is equal to the sum of the first 2. The 3 is the sum of 1 and 2. To get the 5, it's 2 plus 3. So to work out this pattern, we add the 2 previous terms. See if you can work out the first 25 numbers in the sequence, write them in the space below. I leave that for you to do, and you can do a simple internet search and you'll be able to find those.